start recording. So you should see a PowerPoint in front of you, yes? Just to double check, and it's full screen. You have a little pointer. Oops. Yes? Can someone confirm with a thumbs up or something like that? Okay. A raise of hand. Okay, thank you. Okay, great. So right now we're in statistics, okay? It's a little shift for those considering on taking AP statistics later in their careers. This is what it's like. It's less math calculating and more of the interpreting data. If you liked some of the ideas minus the coding part from our data science unit, then this is the stuff for you. It's going to take a couple days, so probably Friday we'll get to this idea of median IQR versus mean and standard deviation and comparing data sets. So that's our goal, to answer questions like these. But it's going to require reviewing a bunch of skills. Maybe you've not heard of these things before, so we'll take it one step at a time. So what is statistics? It's the application of probability theory to make sense of large quantities of data. This field is getting more and more important now, as you can imagine, when there's so many people online doing all these things, and someone somewhere is probably keeping track of those numbers and those descriptions, and we have to make sense of it. Like every time you do a little Google search, someone is tracking that data and suddenly you get a targeted ad on like, oh, this is something they predicted you'll need. With data, there's lots of variability and it helps us make decisions. And we're studying some of the basics from there where we try to come up with one number to describe the entire data set. So you may have heard of these words like mean or correlation coefficient. Those are statistical measures. Numbers are great, but there's also many representations of data, and this was the optional section in your term paper. Numbers and words all listed out. It's overwhelming at times, so that's why we have these other representations, these visual representations of data. So starting with the most basic one, you have a pie or a circle graph. So over here, here's an example of one of different radio stations and what music they play. The benefits of a circle graph are for words, right? That's categorical data versus quantitative data, that's numbers. So that's what pie graphs are useful for. And the one constraint, or what makes them like the main idea behind it, is that they're really good for percentages or proportions. And proportions just means parts of the whole. For pie graphs, you have to show the whole thing, right? In this case, these are all the radio stations, like in the US, for example. All of them have to be present. You can't just have little parts of these. So that's one of the drawbacks. Like you're not always going to use a circle graph for like data unless you know the whole thing. And usually you'll have some computer or write some code or put into this other kind of website to help you generate these pretty pictures. Okay, the next one up are bar graphs. I thought I put pictures here, but it's one step up from a pie graph. As long as you have the same unit of measure, you're good. And now the flexibility here is that you don't have to show the entire thing. You don't need the whole to be present. But here's the interesting part. So I remember why I didn't have pictures here. They can lie to you in ways, statistics. So here we have some examples. Here are your bar graphs. Okay. This one, you can call it like a pictogram or something, or pictograph. What do you notice is wrong with any of these graphs down here? 1, 2, and 3. Here's the original data of people that owned certain kinds of computers, Mac versus PC or none. So if you're watching at home, you would pause and kind of think about it. For people joining me right now, any ideas? No? So over here, you notice the pictures, right? If we notice this picture, you notice the Mac is the one that's the biggest, right? But if you look at the scale of this picture, like it takes up this much area, our eyes are drawn to this like rectangle, the space that it takes up. Well, that means it's like more than like 10 times the size of the Windows or the PC. But you notice in the data, well, that is not the case. Macs only have like 355, and it's not like 10 times bigger than like these PCs. So this one um, skews your sense of like scale by having these big pictures here. Bar graphs, they only show one, should only show one dimension that's going up and down, like the heights of your graphs. This one's lying to us because it uses area, these pictures. And for these two, there's also that same idea of lying happening. If you notice carefully over here, notice where the axes started for this pie graph versus this one. So in this one, it starts at 0. And then for down here, it starts at 10, which kind of effectively chops these two, the people that don't have computers or PCs, down a lot. And suddenly you're like, wait, so PC is like near nothing? Like, no, it's about still like 17%, but you lost some of the data there, right? They're trying to lie to you and saying Macintosh is like the vast majority, to the extent that it's like, what, like 20 times the number of PCs here, if you were to stack these little green rectangles on top of one another, and that isn't the case. And then another idea from this one, because they changed the starting value, is like, notice PC here is not even half of the people that have no computers. But if you look at your original data, well, they're actually kind of close. They're within 5% of one another. And it's not the case that like half of the people that don't own computers, or there's like half as many people that don't own computers versus PCs. But you would think that when looking at this graph. So that's how they're lying to you or deceiving you. Deception. Okay, next one. We have other visual representations of data. We kind of looked at these in the beginning of the year. Now we're shifting to just numbers. Previously for these and for pie charts, right? Those contain categorical data. Those are words. And now, let's say you have a bunch of numbers. You would use different representations to show those. Here is one of the most basic ones, a dot plot. All it is a number line and dots occurring to where those numbers appear. So in this case, it's the number of goals scored in like a soccer match or maybe over a season. And now you can see more things from your data. Your goal here, when we have like this representation, is like what overall patterns are present. You're going to think about these things, and you may hear some familiar words like shape, center, spread, and outliers. Maybe we'll start at the bottom and go up because it gets more complicated. So outliers, it's probably going to be these ones. Somehow they scored 13 or 14 goals. I don't know how that happens. One of my students told me like once you score a lot and the other team is like really bad, then you wouldn't get here because that's like uh, politeness or some kind of soccer idea. I don't understand. So usually soccer matches, there's like down here, right? So for spread, notice it like the graph that's currently showing, it goes from 0 up until 14. That's like your range. Your spread is from 0 to 14. You have numbers all between 0 and 14. Center, we're going to talk about other measures of center soon, but right now you think about this. Where's the middle? Like, is it around here with 7 goals, or are you thinking about your data where the middle is between like all these number of goals, like somewhere around here maybe? That's center. And then these ideas, the shape of your graph, now that we have a bunch of dots, imagine, okay, where does it peak? Is it symmetric? Is the left side the same as the right side? Does it have the same shape if you were to have a line down the middle? Is it skewed in a certain direction? So here are some more examples. right? In this bar graph, whatever data it is, notice it has two peaks. It's almost symmetric because you have one peak, and then right around here you have another peak. Same graph over here, and then this one is test scores, kind of the typical arrangement, right? You have people that have like C's, B's, and A's. How nice. Most people got A's on their tests. Okay. This one has a range or a spread from 70 up to 100. There was no one that got lower than a 70. For this one, it goes from like 1.5 minutes up until 5 minutes. So those are different spreads that these graphs have. And you'll also notice they have different shapes. This one peaks towards the right. This one has two peaks. Our original soccer goal was towards the left. This one has outliers. This one, not so much. This one, you could maybe call 70 an outlier. Certainly for me, if this was test scores, then I would check in with the student. Okay. And so in terms of shape, it's kind of weird. These two words, skewed left and skewed right. Because when you see this kind of graph, like over here, as for the number of siblings, your eyes are drawn to where the majority of the dots are, and you would probably say this is skew left because all your data is there. But that's not how this vocabulary works. This one is actually skewed right. You look for the tail of your data, where that occupies. So here's a nice little graphic. This one is skewed to the left because this fellow, Mr. Starnes, is skiing down the mountain, and that's where he's headed, okay, towards the left. So for like a check for understanding, like you can type into the chat or you can just say it. Would you rather have your test scores, like if I gave you your final, would you prefer it as a whole class to be skew left or skew right? What would you like your final scores to be, preferably? Skew left or skew right? Right. Okay. So you want your, wait, hold on. Okay, so, all right, for the people that participated, right, this one is the graph that is skewed right. This one is the one that's skewed left. So for those people that are saying you want your final scores to be skewed right, you want everyone to do badly. Okay. And so where would you want to be if your graph for like finals looked like this? Oh my gosh, really? All of you? Okay, so you want your test scores to look like this. You want the majority of your class to like do badly, and then you're probably one of these two dots, right? How selfish it is. Okay. But for those kind-hearted ones, right, and me as a teacher, I'd probably want the graph like I was hoping you all would say it's skewed left, right? Everyone's doing well. The majority is like in the A, B territory, and there's fewer people down here. Some people get 100%. That's what I would prefer. I'm less selfish, and I want to pass all of you, okay? So for those that said skewed right, which would look like this graph, okay, you can be a little mean, but just make sure that you get the correct vocabulary. Okay, fine. Yeah, we'll talk about that. So, like, how is this most interesting? Well, like, you think about later, like, probably tomorrow's lecture, um, we'll talk about how people and teachers, like, later on in college, or maybe for AP classes, how they curve, right? If you're, like, if it actually ends up being a skewed right, you're like, let's say this is the test scores, well, then I'm not going to fail, like, two-thirds of my class. And then, or like, this is the final grades, right? Everyone's, like, down here and then a couple people pass, like that's a problem. If I fail like 90% of my class, someone's going to complain. So it's likely that I have to curve this thing. right? I have to set like, okay, maybe over here is the passing score, and now there's more people that pass. So that's where it's interesting for you as students. Okay, so a couple more histograms. Think about these like fancy bar graphs. All it's doing is taking a dot plot you had before, and then this is the data range now, right? So this is 0 to 5 percent foreign-born residents, right? So then here, that range, all these dots, if you had like 1% or 2% or like 3.4% or so, all that gets put into the same category. And then what they do is they draw bars to represent that. So it squishes your data. Now it has this kind of shape. But you can't tell, for example, some of the data that's hidden is because of this range. You can't tell how, like, exactly how many people had like 4% foreign-born residents. Some of that data is lost, but histograms do show you like clearly that this one is skewed right because you look for the tail, skewed right. And this is the process. Often you'll see histograms given with like box plots because it's annoying to show like all these different dots. Imagine having like a billion data points. You don't want to see a billion different dots. You'd rather interpret like the heights of these columns instead. And like in AP Stats class, you most likely don't have to make these by hand. You'd use a tool like your graphing calculator or something. You just punch in the numbers and it gives you these things for you to interpret. Some questions you may have, okay, histograms, if they're fancy bar graphs, then what's the difference? On the right here, we have a bar graph. On the left, we have a histogram. Well, bar graphs, they're really good for words, right? Categorical data. Histograms, you can only use those with numbers, quantitative data. Bar graphs, they can compare the sizes, okay? And then that size idea is like lost. So you can't really tell, like in here, like which state had the most foreign-born residents. You can just tell that, let's see, there's like 2% of states that have more than 25% of their residents being foreign-born. That's all you can tell from there. No specifics. Versus here, I can tell specifically there are 6% stations that like play Spanish music. Like bar graph, you can answer the most or the least of a certain data set. Similar but different, and often you'll see them represented bar graphs. They often give spaces between their bars for this reason. And histograms, because they're little ranges, these bins or buckets, that they're all next to one another. Okay, so the last idea I'll cover for today, besides these like 1, 2, 3, 4 representations of data, are hopefully some ideas that are familiar for you: mean, median, and mode. So for this one, right, the mean, I hope you're most familiar with that. That's the average. You add up all your numbers and divide by your total. So in this case, there's 20 numbers, so I add them up. I get some really large number. I divide by 20. The median, okay, and mode, often you'll get these two things mixed up. Median, that's like middle. You have to sort your numbers first. So in this case, down here, it's not sorted, so I have to put them in order from like least to greatest. 5 is at the bottom, 85 is like all the way up here, and then I sort them. And it's nice when you have one number being in the middle. And then you like cancel out things from like side to side. And then you have one number there. But sometimes, like in this case, where you have 20 numbers, and suddenly you have two numbers in your middle. What do you do then? Well, in that case, you find the mean of those two numbers, add them up and divide by 2, and that's how you find your median. The mode, it's the number that appears the most. It's another measure of center. These three numbers are often talked about together. So if you stare at this graph here, like this data set in front of you, I think 15 should be the mode. It appears 1, 2, 3, 4 times. 60 appears twice. I don't see any numbers being repeated. And we will use these categories in tomorrow as a lecture when we talk about box plots and scatter plots, and then eventually get to this idea of standard deviation and with mean. So to get some participation here, for fun, I have four like bar graphs here, or you can think about them like histograms. Um, for those that are here, can you give some examples, A, B, C, and D, on what these graphs could represent, or what you think they could represent? And it serves as some kind of exit ticket for today. Can you type it out? Okay. Are all of these test scores the strong-spirited one? Or A, B, and maybe not C and D? Okay. And why? So, like, that's kind of messed up, I think. Like, why do you want so many people to do badly on, like, on a test? Okay. So, the strong-spirited one is saying, this is test scores, right? A lot of people failed. A few people passed. This one's even worse, right? It's either all or nothing, like a okay, and now you're saying it's a math teacher's class, right? Most people fail and a couple people pass. That's terrible. This is like pass, no pass, right? No passes here, passes here. There's only two options. I hope you notice that. It's like yes or no. Amount of toilet paper, A, B, and D. Amount of toilet paper, A, B, and D. So this is like before COVID-19, right? Or mass, right? Mass hand sanitizer, toilet paper before COVID-19, it looked like this. You know, some stores they carry it, others maybe not so much, and then there's some suppliers that carry a lot of it. Which one's going to be the middle and which one's after? Like, if it's toilet paper, hand sanitizer, or mass, what's the order for B and D? Give me some more context. Infectees could be D. Based on what? People infected by COVID virus, COVID-19, coronavirus, based on what? Over time. Hmm. Yes. Although, if you were to mention time, you wouldn't use that much of a bar graph to represent that. You probably use like a line plot or something to show change over time. C could be the energy level throughout during the day. So you either have a lot of energy or no energy. Okay, that could work. Any other ideas? Okay, so maybe I'll ask an even more specific question, then I'll send you off. Like, amount of color on the screen. I have energy all day except the morning. Okay, it could be motivation throughout the day. So again, you have this idea of time on your x-axis. Very interesting. Okay, so maybe last thing throughout the year. Okay, so which one of these could be like how many minutes you typically study on weeknights? B. Who studies? D. Wow. Okay. All right. So, okay, cool. I can see why. So, like, strong spirited, what is study? Great. So, right. So, maybe, okay, so B is like interesting, right? So, it might fit a lot of us at Lowell's because, like, people don't study that much until it's right before the test and then they study a lot. So, that's like, could be what B represents. Here, they might be people just people study not so much, and then they study in longer bursts, maybe approaching the test. And then someone on a more regular basis could be studying for longer amounts of time or somewhere in the middle. And then some days they study more, and other days they study a little bit less, but they have more of an average. Cool. You've made sense of these data representations. If you want to get a head start with tomorrow's lecture, you can look up stuff for box plots and review the stuff about scatter plots. That's today's lecture around representations of data and how they could work. Okay, see you all later. I got a department meeting.